Okay, so just for video, we're talking about one-sided limits. We did a quick graph of a piecewise function, and we showed the limit from the left was 4, the limit from the right was 1, and we wrote notation. Left-handed limit, its limit as x approaches 1 with an exponent of a negative sign. Right-handed limit is limit as x approaches 1 with an exponent of a positive sign. And then one last little thing that we wrote here, which I'm going to zoom in on, is that if the limit exists and is big L, then it must be that from the left and the right. All right, so let's get into our example. Okay, so here we go. All right, so first one, suppose the limit as x approaches 5 from the left of f of x is 12. The limit as x approaches 5 from the right of f of x is negative 3. That f of 5 is negative 3. Tell me, what is the limit as x approaches 5? Okay, in your groups, take a minute. Talk about this, see if you can come up with a consensus.
Sure.
How do you know that for sure? Because he's just talking about the limit. I'm not drawing a graph. Yesterday I tried to switch on instance of John. There's not enough room in my class. Are you big enough?
For a newspaper?
You have to have a 90 average.
For a newspaper.
Yeah. No, it is.
Oh, I hear such awesome mathematical discussion. This is fantastic. All right, did all groups come up with an answer? So, what's the answer? Is it 12 or is it negative 3?
Neither.
Neither? What is it? D and E. Why is it D and E? Not the same from both sides. Now, instead of writing not the same from both sides, we're going to use even better mathematical notation, and we're going to write D and E because, and I'll put it up here so you can see, the limit as x approaches 5 from the left of f of x does not equal the limit as x approaches 5 from the right of f of x. All right? When you write the limit from the left does not equal the limit from the right, that is the fancy way of writing not the same from both sides.
Does the College Board have a preference?
Yes, they want that.
Do you have a preference?
Yes, I want that. Okay?
I can use a College Board.
No. Because I don't know, are you allowed to be a teacher and work for the College Board? I don't know.
You can be great.
You can be a reader, you know. All right. Put same problem.
C.
Slightly different answers. Have another quick discussion.
12 guys. It's 12 guys. But it wouldn't be continuous because there'd be a hole right there. Right?
You're absolutely right.
Boom. Got this continuous stuff down.
Okay. So what's the answer to this one? Ooh, I heard a D and E and I heard a 12. No, anyone say negative 3? Does the limit from the left equal 12, which equals the limit from the right?
Yes.
Then that has to be the limit. Must be the limit. If the limit from the left is a number and that equals the limit from the right, then that means that that absolutely without fail must be the limit. Okay? Do you understand that?
Yeah.
No matter what the function is, the left and right agree and they're pointing at a number, that's the limit. All right? Good. Okay, now we're going to get into continuity. And there are 3 conditions for continuity which you've already written down. For the camera, I'm going to zoom in on them real quick. There they are. Okay, so if you are watching this on camera, freeze right there and write those down. Okay, good. All right, so anyway, so we're going to do it's up too high. We're going to do a quick example, 4 examples in your groups of just determining why a function is discontinuous at a particular spot. Now, when you walk through the 3 conditions, you have to walk through them in order. So the first thing you have to check is the function defined? If the function is undefined, that's your answer and you're done. If the function is defined at that point, then you move to the next one and you ask yourself, does the limit exist? If the limit doesn't exist, that's your answer and you're done. If the limit exists, then you move on to the 3rd condition. Does the value of the function equal the value of the limit? And if they're not equal, then that's why it's discontinuous and then you're done. So you walk through them in order. Always do them in order. So what we're going to do is I'm going to tell you the following 4 functions are discontinuous at x equals 3. And in your groups, I want you to take a second and tell me why. So the first one is going to be that one.
Jump discontinuity.
Okay, but jump discontinuity is not one of our reasons listed. Okay, so you have to be very specific and use those 3 conditions.
Limit f of x
And then the first one
not
is
equal
f
to
of c must be defined. It's not. And the last one is the limit doesn't exist either. So she'd be playing with us. She'd be toying with our heartstrings.
Wait, no, B is so we're trying to find
And then the last one is the limit of x approaches c is not equal to c.
Alright, so in your groups, figure out the reason for all 4.
Alright, who wants to write it down?
I'll just say it out loud.
Okay. Yes, of course.
She wants to know quantities of students.
You guys already did all 4?
We didn't write them down though.
You didn't write them down? Sometimes it's helpful to have these things in your notes. Because they might appear like on a quiz or a test.
Like word for word problems?
Similar.
Similar, yeah. Write it down.
Yeah, I'll write them down.
We'll photocopy them.
Yeah.
Every day, we should
Do you know that there's actual value in the writing that there have been studies that prove that you
We
learn,
learned that.
yeah, that you learn by
Yeah, we
writing
did
things
miss that.
down.
I can't waste the ATP though, so I'm gonna get like tired.
That was AP Bio right there.
The ATP, what's
It's like what
Adenosine
your
triphosphate.
your body breaks down glucose to form that. It's like what your cells use as like really quick energy.
you need that for writing?
Yeah, I
You need it for
I
like
need to
consider
consider
anything.
Okay.
Like right now, like this.
Okay, anyway, let's just work through these. So for this first one, you ask yourself, is f of x defined at x equals 3? Yeah, if there's a point there, it's defined, right? So that's not the reason. So why is this function discontinuous at x equals 3? The limit does not exist. So this one is discontinuous at x equals 3 because the limit as x approaches 3 of f of x does not exist. And if you wanted to be like extra special, you would say because the limit from the left does not equal the limit from the right. Do you understand that?
Do we have to write that?
No.
Okay.
Stating the limit does not exist is adequate. All right, for letter B, is g of 3 defined?
Yeah.
No.
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 No, is there a point there?
No.
No, so that's your answer. G of 3 is undefined. What about for letter C?
The limit doesn't exist.
Limit doesn't.
Ooh, are we doing them correctly in order? What do we check for first? Is h of 3 defined? No, that's your answer. H of 3 is undefined. Now, if you wrote the limit as x approaches 3 of h of x does not exist, that would actually also be correct. But I'd like you to check them in order. In order. All right, letter D. Is P of 3 defined?
Yes.
Oh, definitely.
Does the limit as x approaches 3 of P of x exist?
Yes.
So why is it discontinuous?
Because limit of f of x
Does not equal f.
not equal c.
Okay, except P of x, right? Guys, watch out, because it's time for us to start moving around and switching those function names, right? So be very careful if we give you P that you write P and not F. So the limit as x approaches 3 of P of x does not equal P of 3. Okay, does everyone understand those 4 things? Okay, the last bit of notes, and then we have to do a couple of really big examples, is to talk about removable discontinuity. So just FYI, if the limit exists, then the discontinuity is removable. Okay? If the limit exists, then the discontinuity is removable. So for these 4, A, B, C, D, A, is the discontinuity removable? No. And so we don't say, what we write for that is non-removable. What about for letter B?
Yes.
Yes, so this one is removable. What about for letter C?
No.
No, because the limit does not exist. So this one would be non-removable. And then what about for letter D?
Yes.
Yes, this would be removable. Now, technically, just so you understand the concept of removable discontinuity, discontinuity is removable if you can change 1 point on the function and remove that discontinuity. So if I changed 1 point and made g of 3 this point right here, then it would be continuous, right? If I changed this 1 point, move the dot to here, this would be continuous. Here, there is no 1 point I can change that's going to bring these 2 sides together. And there is no 1 point I can change that are going to bring these 2 sides over the asymptote. So it's only if you can change 1 point that the function, the discontinuity is considered removable. All right. But for you guys, just know if the limit exists, it's removable. If it's not, it's not removable. That's your go-to reason. All right, you ready for a great big giant example that like covers everything?
Of course.
Awesome.
I'm always ready.
Oh, yeah.
Oh yeah. All right. Gotta get some board cleaner. That on my shopping list. This is just fantastic. Okay. All right. Here we go. A. Find the x value of discontinuity. What? Is everything okay?
Yeah.
Something
Okay.
made a noise.
Find the x value of discontinuity for f of x equals x squared minus 9 over x minus 3 and state y. Why it's discontinuous. Okay, part B. Is it removable? state y, or y not. Part C, if removable, redefine f of x at that point to make it continuous.
There's definitely gonna be a hole there, I can see it already.
You can see it, it's good. Wow, this is a really big problem, it's very involved. I would think this would be a great problem to put like on a quiz or a test.
Zach, probably.
Yes, with this function,
Okay.
yes, yep.
This is my wish in ATP.
Okay, so, part A, you don't have to do any proving, you just have to tell me the x value and state y. So, for part A, anyone know where this function is discontinuous just by looking at it?
3.
It's discontinuous at 3. So, discontinuous at x equals 3 because, go in order, what is the reason?
Because
Limit x
limit
equals
of
C is undefined.
F of 3 is undefined. If you divide by 0, you're undefined. Doesn't matter if there's a hole or an asymptote. If you're dividing by 0, you're missing a point there. Okay? So that's part A. Part B, is it removable? How do we know if a discontinuity is removable?
Change 1 point.
Okay, but for us, what did I tell you? What's our go-to reason? The limit exists, right? So in order to show the limit exists, you have to actually find the limit and verify it exists. So we need to find the limit as x approaches 3 of x squared minus 9 over x minus 3. Everyone take 3 seconds and do that. What are you going to have to do?
Factor it.
Factor. It would not be a good day without factoring, right? That's what makes it Fun Friday is we factor. So what's the value of the limit? 6. Therefore, it's removable because the limit as x approaches 3 of f of x exists. If the limit exists, it's removable. Yes, Jim?
3, she put actually 6.
Oh, that just means therefore. That's a little math shorthand for therefore. Okay, part C. We need to redefine f of x at this point to make the function continuous. So I am going to redefine f of 3 to equal 6. Why would I make f of 3 equal 6? Because that's the value of the limit. And in order for this function to be continuous, the value of the function has to equal the value of the limit. You're not going to change the limit. The limit follows the flow of the function. But you can change that 1 point on the function and say, hey, let's just define f of 3 to equal 6. And now, it's continuous. All right? So you're going to set the function equal to the value of the limit when you're doing this part. Does that make sense? All right, we might have time for one more of these. Let's just give it a shot. If we have to start and the bell rings, then that's so be it. But let's at least give it a shot. So here we go. For you guys in your notes, just write ditto. Okay? Ditto with a new function. So, what's our new function? Oh, piecewise. Here we go. We're going to do 2x minus 5 for x less than or equal to negative 4. And x squared plus 1 for x greater than -4. If you can see that, it's a little squished. So 2x minus 5 for x less than or equal to -4, x squared plus 1 for x greater than -4.
That seems like a fun time.
Doesn't it? I know. I love piecewise functions. Okay, everyone have ditto and just the new function written down?
Yeah.
Yeah? Good. So for part A, here's how you know if this is discontinuous. Well, the top function, 2x minus 5, it's a line. It's always continuous, right? The bottom function's quadratic. That's always continuous. So there's only one x value where the function could possibly be discontinuous. Where is it? At -4. Because that's where they're supposed to meet up, right? And it said where is it discontinuous, so it's got to be discontinuous at -4. But the way that we prove it is we have to find to show that it doesn't meet up. And in this class, the way you show it doesn't meet up is using that great L word that we've been studying. So here's what we're going to do. You can't just write f of -4 equals f of -4 equals. There's only one value for f of -4. And there's no such thing as f of -4 from the left and right. You have to do the limit. The limit as x approaches -4 from the left, and the limit as x approaches -4 from the right. So if we use x approaching -4 from the left, are we going to use the top or the bottom part of this function? The top, because that's where x is to the left of -4. So we just plug in -4 into the top and we get -13. -8 minus 5, right? The x values from the right of -4, we would use the top or bottom? The bottom, and what do we get? Say it loud, say 17, very good. 17, right?
Yeah.
Okay, the limit from the left is -13, the limit from the right is 17, so what's the limit?
It doesn't exist.
Therefore, the limit as x approaches -4 of f of x does not exist. So f of x is discontinuous at x equals -4. That's the hardest part of the problem. Everything else is easy. Part B, is the discontinuity removable?
No.
Why not?
Limit does not exist.
There you go. Discontinuity is non-removable. Oh, I should never write on the board in cursive. I have terrible handwriting. Non-removable because the limit as x approaches -4 of f of x does not exist. And then therefore this one, not applicable because the discontinuity is not removable. Alright? Wow, do you think we have time for one more?
No.
No.
I honestly don't think we do.
Let's see.
My thing's already away.
We do!
No, we don't.
Oh, we totally do!
My binder's already
I'm
away.
not trying to kill trees, Mr.
Alright, now, one more problem. Oh, this is awesome. Okay, one more. I want to teach you guys the difference between the two types of piecewise functions, because you're going to see two different types. One type like the one we just did, and one type like something like this.
He doesn't know the difference between they're all back. So he has to go through every single one before he finds math. I'll write this right here. So you saw the dump is too much stuff. Right there.
So here's the thing. When you have a function that's piecewise and it has this kind of a thing going on, all right, a greater than, less than thing, you have to check the limits from the left and the right. because you're going to have a different function from the left than you are from the right. But when you have a not equals equals thing going on, that means which function, top or bottom, applies to all real numbers on the entire
Top.
number line with the exception of one little dot.
Top.
The top. The top is for every x value in the entire system except for -2. This guy is one dot.
Correction.
Yes.
Send Mustafa to 1340, please.
Send who? Oh, Mustafa. Okay, he's on his way. Okay, so does that one dot control the limit? Can a dot drive the limit value? No. So when we're finding the limit as x approaches -2, which function are we going to use, the top or bottom? The top. The top. Okay, now f of -2 is defined, right? It's 20. So that one, that condition is met. So what we need to do is find the limit as x approaches -2 of f of x. And when we do this, we're going to find the limit as x approaches -2 of the top function.
We got factor sum.
Another factor. Yay, factoring.
You know, they factor.
Can I go?
Yes, you may go.
I think he has like ADD.
Bye everyone, have
Bye.
a good weekend.
Have a good weekend.
Now it's just 2.
Y'all done?
Trying to get rid of everybody.
These are easy I'm giving you easy factoring ones.
You're so nice. That's like.
But that doesn't mean we will on the quiz or the test, right?
Hello.
All right. So bam, bam. What is this limit? It's 1. So f of -2 was defined. The limit as x approaches -2 exists. So why would this function be discontinuous?
Because it has a whole.
Okay. F of -2 equals 20. But the limit as x approaches -2 of f of x equals 1. Therefore, discontinuous at x equals -2 because the limit as x approaches -2 of f of x does not equal f of -2.
Ooh.
That's how you get those functions with the curve, the hole, and the dot, right? You get them with the not equals equals. Yes?
If you did have your second equation that it was continuous,
Yes.
would you still like, for the value for the whole and the value for whatever they meet up at, would you count the, crap. Sorry, no, I forgot it.
You lost it?
Yeah.
Think about it a little bit. Okay. All right. Is the discontinuity removable? Why? Because the limit as x approaches -2 of f of x exists. We want to redefine f of -2 to equal what? 1, because that's the value of the limit. Done. All right. Okay, here endeth the lesson. Now, you will